Everybody, Mr. Gustin back in the physics classroom. I wanted to talk you through question number 4 on worksheet 2 for unit 3. So this is deriving an expression for circular motion. Question number 4, so it's on the back page, and it asks me to derive an equation for the net force, or FnetR, FnetR, of an object moving at a constant speed in a circle in terms of radius, mass, and period, meaning my answer should only have R, M, and T in it. That's it. Start with FnetR equals mv squared over R. So it asks me to start there, and then it basically says derive an expression, so basically change this thing around so that it only includes R, M, and T. Well, there's only one variable when I look at this that it's really calling out, right? Like this problem is calling out v squared. It's saying, hey, you don't belong there, let's get you out of there. So we have to think, what is the circular speed? It's kind of hiding some variables behind it. We've talked earlier about velocity in a circle being equal to the circumference of that circle divided by the period. Well, the period is one of those variables that I'm allowed to use. Radius is one of those variables that I'm allowed to use. Pi isn't a variable, that's a general constant. So I should be able to take this and substitute it into v squared, or v right there, and see what happens. Maybe that is my expression that I should be looking for. So let's try that. Let's do m, and I'm going to bring m over r right here because this thing's going to get messy. So let's do 2 pi r over period, this whole thing squared. Okay? I'm going to kind of keep using the space down below here to keep writing this thing out. F and that r is equal to m over r times. Now we're going to distribute that squared into all of these variables. So 4 pi squared r squared over period squared. All of those things belong there, which means we're going to lose this r. F net r is going to be equal to, it looks like, 4 pi squared r times m over t squared. This is what I have. This is weird. This is an equation that it doesn't make me comfortable. It's an uncomfortable equation with pi squared in it. Just a lot of variables. Let's see if it follows the rules, though, of the derivation. Derive an equation for net force on an object moving at a constant speed. Okay, start with mv squared over r. Derive it in terms of r, m, and t. Well, the only variables that I have are r, m, and t. 4 and pi are constant values. Those things don't change ever. So I guess I'm done. Deriving expressions is weird, right? Deriving expressions means you're going to come up with a new equation that perhaps you haven't seen before, very specific to the equation we're talking about or the situation we're talking about, and it needs to be in terms of the variables they give you. Well, it is. I guess that's it. I guess we're done. That's how you derive an equation. All right? See ya!